Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. And we are discussing the subject called Object Technologies and Programming in Java. And today we are going to discuss the last basic pillar or the building block of your OOPS paradigm, that is encapsulation. And from tomorrow on, or from the next lecture, we are going to start with the actual Java. That is, we are going to start implementing all these paradigms that we have discussed so far. So let's begin with now encapsulation. Encapsulation is one of the fundamental concepts in your OOPS. It describes the idea of building data methods that work on the data within one unit. That is a class. Class is actually a blueprint. So we have all those blueprints with us, and then after the physical realization of those blueprints, that is called objects, we are going to deal with them. We are going to use them to make up our application. Now, this concept is often used to hide the internal representation state of an object from the outsides. Okay, this is called information hiding. I think we have discussed a little bit about information hiding in the last lecture, and today we are going to discuss that in great detail. The general idea of this mechanism is simple. If you have an attribute that is not visible from the outside of an object and bundle it with the method that provide read or write access to it, then you can hide specific information and control access to the internal state of the object. So what we are trying to say here is, suppose in a class we have described a property called as name, which is of type string, and as you can know, we can access the properties of a particular class by instantiating its object. Now, if you want to control that, not every user could be able to change or alter the name property of a particular class, of a particular object, then what we can do is we can impose an access modifier on that particular property, so that not everybody or not the end user can access it directly, but we can set up a method there. Those are called getters and setters method. You are going to discuss those getters and setter methods in the next few lectures. We're going to see how to access those properties which are actually hidden from the end user, and by use of those methods we can control which user can use it and which not, or you can control which type of names are actually permitted to be, or which qualifies as the name of the particular object. Okay, so what kind of data is actually qualifies as name of the object. Okay, so you can place there any kind of implementation to permit only the valid names for your object. So this is what has been described here. Now, if you're familiar with any object-oriented language, you like C++, you probably know that these methods are getters and setters, as we have discussed earlier. As the name indicates, a getter method retrieves an attribute, and a setter method actually changes it. So depending on the method that you implement, you can decide if an attribute can be read or changed, or if it's read only, if it is not visible at all. Okay, that depends on the access modifiers or the availability of your getters or setter methods. And let's look at a live example of encapsulation. So we have this coffee machine example. So what we did here, for example, is when we created the coffee machine class, the attribute config map, beans, grinder, and brewing units, these are all properties, store the current state of the coffee machine object. And the method brew coffee, brew espresso, filter coffee, add beans, implement a set of operation on these attributes or properties. Okay. As you can see, all of these properties here are access modified as private. We have discussed these access modifiers in the last lecture. Okay, and then this is a type of a constructor. Okay, it's a constructor is a type of a like a welcome message where when you turn on a particular machine, it asks you for certain details, and on the basis of that detail, it starts its initial operation. That is what constructor to an object. When you are going to create a new object, instantiate a new object, it is required if the constructor is there. If a customized constructor is there, then that object would require some details from your side, some data from your side, which it requires to functions properly. Okay. Now, as you can see, uh, this dot grinder is equal to all of these. Okay, let's go below, not here. Hmm. Let's see if I have created a new. Okay, this one is going to be a little difficult. Okay, so let's move ahead. Now, as explained at the beginning, I haven't explained this example here because I think it's going to be too much at this point of time. We're going to discuss this once we are familiar with the constructors and objects and classes in at least in the example form, in the live form. Okay. So, and I'm going to show you those getters and setters method from time to time in this particular class. So no need to worry about what are those right now. We are just going to discuss about access modifier for now. Okay, because encapsulation is at the end, uh, is actually achieved by the use of these access modifiers actually. Okay. So as explained at the beginning, you can use the encapsulation concept to implement an information hiding mechanism. Similar to the abstraction concept, this is one of the most commonly used mechanisms in Java. You can find examples of it almost all well implemented Java classes. You implement this information hiding mechanism by making your class attributes inaccessible from the outside and by providing getter and setter method. We have discussed all that. So let's move ahead. Let's talk about access modifier in detail now. Now Java supports four types of access modifiers that you can use to define the visibility of your classes, methods, and attribute. By visibility, I mean who can access your code and who cannot. Okay. Now each of them specifies a different level of accessibility, and you can only use one modifier per class. Okay, so your class could only use one type of access modifier at a time. It cannot be public and private at the same time. Okay, I think you are getting my point. Either you will be protected or you will be vulnerable, but you cannot be both at the same time. It's not achievable practically. Okay, so moving ahead. Okay. So as a rule of thumb, you should always use the most restrictive modifier that still allows you to implement your business logic. So the rule of thumb or the basic convention is that you must make your application as safe as possible. Don't take anything for granted. So you must implement the most restrictive modifier, access modifier, that is your private, protected, or public, for a particular property in your class, such that after the application of that access modifier, you will still be able to use your application to the ease. Okay, so we have four types of access modifiers with us, that is private, and then no modifier. No modifier means we have no mention of any type of access modifier. Yes, there is an option for that. It means you can left it out to your Java compiler to decide. Okay, we'll see how it is being done now. And then protected, and then last your public. So let's talk about private first. Now this is the most restrictive and most commonly used access modifier. If you use the private modifier with an attribute or method, it can only be accessed within the same class. Subclasses or any other classes within the same or different package can't access this attribute or method. Okay, so any attributes means any property or method which have been defined in a particular class and been termed as private as a access modifier will only be accessible to the members of that same class only. Let me again remind you that. So any member that is outside of that particular class will not be able to access that particular method or property. So this is how secure your private is. It will not even allow your classes which are in the same package. So as a rule of thumb, the private modifier should be your default choice for all attributes and internal methods that should not be called from external classes. You might need to make an exception to this rule when you are using inheritance. Yes, because while inheriting from some parent class, you need to access those, let's say, the members of those classes. As we have discussed in the inheritance, the members of the parent class need to be accessed in the child class, because that is the essence of inheritance actually. Okay, and some of the subclasses need direct access to an attribute or internal method. In that case, you should use protected modifier instead of private. Now next is, what if we mention no modifier at all? When you don't provide any access modifier for an attribute or method, you can access it within your class or from all classes within the same package. Let me tell you what in package is. Package is just an complete application, or almost, or the classes of which are actually uh, doing some work of relatable domain, like all the classes which are doing some kind of tasks related to mathematics will be defined in a particular package called math. Okay, so package is just bunch of classes which are doing some individual task relatable to same domain. Okay, so in that way you can see that, let's say, if you have defined a class which is doing integration for you, and if you want your class to perform, let's say, perfectly, then you might need the help of some other class called differentiation and addition and subtraction. Okay, you cannot perform integration without them. So in that case, you will mark your attributes on the differentiation, addition and subtraction class as protected, because all these classes will be in the same package, and then all these classes will be able to access the members of a particular class in the package called maths. If you will term them as private, then the integration class will not be able to access the members of your differentiation class or the methods of it. Okay, so this is how it has been done. Now, if you don't provide any access modifier for your attribute or method, you can access it within your class and from all the classes within the same package. That is why it is often called the package private. Okay. Uh, Sorry, I think I have mentioned that you have to mention that as protected, but if you left your classes with no modifier at all, then the whole package will be able to access those. Okay. Now I use the private modifier to restrict access to all attributes as well as, okay, we'll not go inside there. I think uh, we are done with this no modifier at all. So in the private, only the members of a particular class will be accessed. You will be able to access the property of that class only. For no modifier, all the properties and methods will be able are accessible from all other members of the same package. Now let's get back to the protected. Now attributes and methods with access modifier protected can be accessed within your class by all classes within the same package and by all subclasses within the same or other packages. Okay, the protected modifier get mostly used for internal methods that need to be called or overridden by subclasses. So this is mainly used between your parent and child classes. You can also use it to allow subclasses to access internal attributes of superclass. Okay, it is not very widely used actually. While using the let's say parent child or is a relationship, that is inheritance, we normally use public or private. Now let's get to the last one, that is public. Now this is the least restrictive access modifier. The methods and attributes that are public modifier can be accessed within your current class and by all other classes, so there is no restriction at all. The public method and attributes become part of public API of your class and of any component in which you include them. Now that is almost never a good idea for any attribute, because everybody will be able to watch your code then, any other API. If a method is publicly available, you need to make sure that it is well documented and that it robustly handles any input values. Okay, so that not any kind of garbage value can be or can take place of any property. Okay, or can be assigned to any property. Okay, so one more thing that I have to show you is this uh, table here, which actually will be good for you to remember that what kind of access modifier is used and what kind of accessibility it offers. So let's talk about first the column called modifier. So for private, inside the class, yes, everybody inside the same class will be able to access it. Inside the package, no. So if a particular attribute is defined as let's say private in a class, let's say its name is A, then all the members of class A will be able to access that. But if the class A is in package, let's say B, then no other class of package B will be able to access the property of class A which has been termed as private. Okay, and same is the case with subclasses or any other class. So private has a scope inside a, not scope, but I will say has accessibility inside that particular class only. Next is no modifier. For no modifier, all the class and the package are good to go, are good to access. So all the classes inside the package are good to access any property of that particular class. But no subclasses or any other classes outside the package are allowed to do so. Now inside the protected, any class can, within the class, yes it is, within the package, yes it is, and any subclass which is not the part of this package but actually inheriting this class will be able to access the fields of the class which has been termed as protected. Okay, so protected is a little bit more relaxed version of no modifier, and for public there are no restrictions at all. So all you have to make ensure that if a particular term field is public, that particular class is in your application that has been imported by you. That is it. So I think I have made myself very clear about all those access modifiers, and we have seen what is the meaning of encapsulation. We will see encapsulation in action in next few lectures when we actually dive into Java. So for now, I'm going to end this lecture now. Thank you.